Hi all, welcome to this yet another webinar from Geeks for Geeks, which is cracking the system design interviews, which is a part of a series of winter interview preparation series. And this is going to be pretty interesting as we have Priyansh with us here, who is our in-house mentor. I'll quickly invite Priyansh over to the stream. Hi Priyansh,
Hey, Sheil, how are you doing?
how are you today?
I'm good, man. How are you, Sheil?
I'm also good. So, Priyansh, can you please give a brief introduction about yourself and about this webinar? What is special about today, and how is it going to help our students?
Yeah. My name is Priyansh Goel. I graduated from Triple IT Allahabad in 2015, and I have almost now 6.5 years of industry experience. Right now, I'm a senior software engineer too at Sumo Logic, which is a startup in log search and security domain. Right. That is there. I'm leading on the ingestion side of things and on the search side of things. Apart from that, I worked at companies like Amazon and Walmart where I was working on the detail page and the fulfillment side of things. So I was working in detail page at Amazon where I was handling almost like 70,000 TPS kind of scale worldwide. And I was also working at Walmart on the fulfillment side of things where we used to fulfill the e-commerce orders in store for the US and as the marketplaces. So that is pretty much from for me, right? At Sumo Logics, I've been so Sumo Logic is more of a B2B log search and management, which is working in log search and management area at exabytes of kind of data scale, right? So we deal with exabytes of data per day, um, and that is our everyday job, to be very honest, right? Apart from it,
Okay.
I am an in-house mentor at Geeks for Geeks, where I, help people with system design interviews, help them crack it, and also take classes over there to help students crack system design interviews and get them clarity on the concepts and the fundamentals of system design. Now, as you mentioned, right, why this is going to be very interesting and very important webinar is because, as people grow older in their corporate journey, especially on the tech side of things, right, coding interviews are important, but system design kind of takes the upper seat, right, where it is very important for anybody who is between, let's say, 3.5 to 3.5 years of experience plus. You would, when you want to move to a layer of SD2 or senior engineers or principal engineers, right, you need to have a good grasp of system design, right? Because at the end of the day, your algorithms and the problems that we try to solve via coding are designed to help run the systems, right? And a system consists more than what an algorithm is, right? A system contains a lot of components, a lot of chunks, and we should be able to kind of, you know, inculcate them, use them, try to, we should be able to figure out how these systems work in together, right? So for senior positions especially, system design is a very important round that I think almost all the companies in the industry look for, because for freshers or for junior engineers, coding is one competency that they look for, but for senior engineers, along with coding, system design and the thought process around system design becomes very, very important.
So, Priyansh here is the perfect guy for you all here to talk about all things system design and everything. And okay, sure. So, quickly, let's start this session. And also, this is for the audience. If you have any queries, anything you want to ask Priyansh, you can add in the comments below. I will one by one address each one of them. So, Priyansh, all the best. You can take the lead from here.
Sure, Shil. Thank you.
Thank you.
Cool, guys. So, what I'll do is, I'll, give me a minute. I'll just share my screen, and we can use that to, yeah, cool. So let's first try to understand what a system design interview is and why do we need a system design interview, right? Now, a lot of people, actually ask this question, right? Why the companies ask such questions where you are asked to design a real Twitter in 45 minutes, right? That is impossible because nobody can design the complete Twitter in 45 minutes. And that is true. When you say that, that is kind of true. But the companies, when they ask for a real Twitter in 45 minutes, they're not really asking you to design the cent% correct system in 45 minutes. That is what not the round is all about, right? The round is mostly about your approach, understanding your thought process behind how would you go about solving it, right? When you're given such ambiguous problem, you know how do you think about it? Are you able to break it down, right? Are you able to figure out what the functionalities would be? Are you able to figure out what all things you need to be able to support this? Are you able to figure out what scale we need to support it, right? So a lot of problem solving mechanics in terms of how do you think about it, and then a lot of computer science fundamentals also come into picture when somebody asks a system design question, right? Because let's say if you choose a particular database, right, people would ask, why did you choose a database, right? Why did you choose a NoSQL over a SQL or a SQL over a NoSQL, right? And those kind of questions kind of expose how well people know their computer science fundamentals, right? So let's say if you say that I'm going to store this in memory and not on disk, then do you really understand why do you need to store this data in memory? How did you judge that, right? All of these questions are basically what people are trying to find out. So they want to, like, there are two fundamentals, right? There are two things that people are looking for. First, are you able to solve the problem in by removing all the ambiguity, by figuring out what you need to do? And secondly, are you able to take care of the computer science fundamentals that you need to solve such problems? That is why companies ask such big questions, because in senior engineer roles especially, you're not given a a well-defined project, right? You will have a well-defined problem, but you may not have a well-defined approach of doing it, right? And you will be expected and asked to figure out the approaches yourself, figure out what you should do and what you should not do, and then come up with some proposals, right? So that is the system design interview also try to emulate in the way that you're given a problem and you are asked to figure out the approaches and then maybe provide a trade-off so as to why do you think this approach is better than that, right? So all of these are very important in a system design kind of an interview, and that is why people ask such questions in system design interview. Okay, another question that people ask is that how can we design systems that we have never designed any like that we have never designed? For example, if you ask me to design Netflix, and if I have not worked on any video streaming platform before, then obviously it is going to be pretty tough for me to design Netflix, right? And it's understandable. Okay, people are not expected to design the whole system correctly in the most optimized fashion, right? That is not what the expectation is. The expectation is that the person should be able to understand whatever he or she is proposing, right? And or she should be able to figure out the trade-offs in their design. So let's say you have, for a particular system, you have two or three approaches. You should be able to at least compare those two, three approaches and figure out that what is the right one, what is the wrong one, where this would work, where this would not work. All of that is what is expected. So you're not expected to, let's say, know of all the things in your system design interviews. It's not expected, right? The only expectation is that you would know the basic fundamentals of your computers, right? Of your distributed systems, of any systems that are required, and apart from that you would be able to use them and solve any problem that is given to you, right? But this need not be the correct, like 100% correct solutions, right? No design is completely correct, to be very honest. What suits you for one kind of problem or one kind of scale cannot be the same design that you would go for in another kind of problem or in another kind of scale, right? So that is why you don't have to worry about in the terms that you have to design a correct system. It's just that you have to be able to discuss trade-offs with to watch approach you are taking, and is that approach right or wrong, and then should be able to justify the approach that you are taking, right? That is what the motive is as well, right? So that is why you don't have to worry about designing the right kind of system. Even if you have not designed it, you should be able to think about it and propose few approaches of designing that problem if that problem was given to you. Okay, so what exactly is a system design interview? We have already talked about why and how, right? Let's first figure out what a system design interview is. So system design interview is, as I mentioned, it is basically two things, right? It has some sort of problem solving. Why? Because let's say if I say that design something like YouTube, right? Then you would have to have some problem solving capability of understanding how would YouTube work at the end. Finally, it would be using some algorithm, right? Or something deep down, right? That you have to figure out, that you have to uh, get with. So it is problem solving, but then it also requires the knowledge of how to build the robust scalable systems, right? And that is very important. That is where your concepts, your fundamentals kind of get out. Whereas your coding interviews are only checking your ability of problem solving, right? They are checking how good are you at algorithms. They are checking how good are you at data structures. They are checking how good problem solver are you are, right? Are you able to think about a problem? Are you able to break it down? Are you able to solve that problem in the most optimized fashion possible, right? Whereas system design is not only about that, it is also about how are you able to communicate with the interviewer in terms of your approaches, in terms of your fundamental concepts, right? And then what decision do you make, right? If and are you able to justify your decisions that you are taking? Let's say if I say that for this particular system I am going to go ahead with Cassandra, right? Then I should be able to justify my choice of Cassandra with a particular uh, reason, right? Which could be anything, which should be a logical reason. If as long as I am able to do it, the that is all fine. Okay, so how system design interview works? Questions normally are pretty big, and that is true, right? Let's say if I write design Uber, okay, or design Facebook, you cannot cover all the features of Uber in 45 minutes. You cannot cover all the features of Facebook in 45 minutes. That is impossible, right? These companies have taken a lot of time to come up with all the things that they have done, right? So you cannot be expected to do everything in 45 minutes. The goal is that you should be able to take this very vague question and then convert it into a 45-minute discussion. Now, how do you do that, right? First is that you should be able to understand what all requirements you need to cater to. That's it. Get get an agreement with your interviewer that I am going to only take care of these requirements, and I am not going to take care of any other requirements apart from this. Right? Get that clarity. So if you see, scoping is very important part of a system design interview, and if you see this is how your real life um, problem solving or your real life job also works, right? Because you're given a big problem, you are kind of expected to break that problem into smaller sub problems, and then you figure out that maybe for the MVP we'll just do this one, for V2 of the product we'll do these many tasks, and so on. Similarly, people expect you to do this in the system design interview as well. Secondly, never this, as I mentioned, right, the system design interview is never objectively correct or incorrect, right? You have multiple approaches of solving a particular problem. You just need to be sure that which solution you are going to go ahead with. Why did you make that choice? You should be able to logically explain this to the interviewer, that why did you make this choice, right? Because let's say if you were comparing two DBs, which was, let's say, Dynamo versus MySQL, right? Then you should be able to understand, or you should be able to explain to the interviewer that why did you choose Dynamo over MySQL, or why did you choose MySQL over Dynamo, right? So that becomes a very important part of the system design interview. And let's say there is a possibility, right, that you're thinking in the wrong direction, or you're not thinking the whole case thoroughly, right? Or you're missing something. Then whenever the interviewer is challenging you, you need to make sure that you're incorporating that feedback. Or if you think that your design is correct, then you should be able to defend that design from that question, right? So for example, if let's say somebody asks, right, that why have you used MongoDB or Dynamo or basically any NoSQL DB when this system needs more strong consistency, right? And we'll talk about all of these things in later part of the webinar, but for now just bear with the words, right? So you should be able to either correct it, or if you think that the system is not strongly consistent, then maybe you should be able to defend that the system is not, we don't need strong consistency over here, and so I think Dynamo works better than MySQL for this case, right? Both of these are correct as long as you're able to give the correct logical explanation. People are going to be okay with your system design interview performance. Okay, so let's just talk about the design fundamental categories, and then we'll actually talk about them. So what is fundamental knowledge? Fundamental knowledge is basically the knowledge of your computer systems, right? How does your like computers work? How does your systems work, right? Why do you say that, like if I say that RAMs are faster than disk, right? Why is that, right? Or let's say, why do we need a particular system to be broken into microservices, right? Why do we need sharding? All of these are pretty much buzzwords that you must be hearing day to day, right? But you need to understand that why do you need them. What is, let's say, if I talk about sharding, what is sharding, right? Why do you need sharding? Do you need sharding in every database, or at what scale will you start needed sharding, right? So all of these questions are important to test your fundamental knowledge about any topic. Similarly, I can go about replication, right? Like, what is replication? Why do you need replication? How will you do replication? What are the various models of replication, right? These are all your fundamental knowledge that you need to know about any system that you're designing. Next is the key characteristics of a system, right? When I talk about key characteristics of a system, key characteristics would basically mean, things like your non-functional requirements kind of a thing, which basically would mean, let's say, what latency you want to have your, what is the latency of your system that you want to support with? What is the throughput of your system that you want to support it? What is the availability that you want to support it? Those things, right? And we'll discuss all of these terms in some time, but that is how these that is what is basically meant by the key characteristics of your system. Actual components of your system. So let's say you are given the task of designing Facebook, right? But what all would it contain, right? For example, it would contain some load balancer, it would contain, let's say, some cache, it would contain some microservices. What all microservices it would contain, what all databases it would contain, all of that becomes an actual components of your system. Now a lot of people ask that, do I need to know the real tools which are used as components? So let's say, for example, if I say that I'll use a cache here, do I need to know an actual cache which exists in the system, right? So it is not compulsory to know that, right? That you may not know about Memcache, you may not know about Redis, right? And that is okay. As long as you understand that there is some distributed caching that I would need here, it's completely fine. The only challenge is that, let's say, when you say that I'll be using Redis, right? Then use that name only when you have confidence about it, right? Because people are going to then maybe ask some questions about Redis. So as to, why did you choose Redis? Why not Memcache? Kind of a thing, right? But as long as you don't know it, as long as you don't mention it, you can go by generic terminologies, and you can very well tell that, okay, I have not worked on uh, Redis, or I have not worked on Memcache, but I know that a distributed caching would make a good case here. Those kind of things are okay, but you don't really need to know the real tools. If you know, it's always good. Why? Because it makes your whole case easier, right? So let's say if you say that I'm going to use Redis, right, and you have worked on Redis and you understand Redis easily, then you would be able to figure out what the semantics of your distributed cache would look like and everything. That all becomes a lot easier, right? So if you can, it's great. Otherwise, it's not compulsory to know all of this. Okay, so let's talk about key characteristics of a system. The first characteristic of a system is availability. So how do we define availability? Let's say I am getting 100 requests to my system, right? Out of which only 99% of my request get successful response, and 1% of my request get uh, like failure response. Okay, then my system would be called that my system is 99% available, right? Because only 99% of my requests are getting answered, right? That is how your availability is defined. So availability is mostly defined as things like two nines, which is 99, three nines, which is 99.9, four nines, 99.99, five nines, 99.999, and so on and so forth, right? Now, you cannot, like, ideally, theoretically, you can achieve 100% availability, but it's almost impossible to do that, right? Why? Because there are two reasons for that. Because you cannot, because if you are going to cover for 100% of your availability, you are going to over engineer system, right? Because let's say if there is that a node, but a particular node can go down anytime, right? Your systems could go down anytime, right? There could be outages in your system. Now you can take care of a lot of time by doing some engineering, but sometimes the amount of effort that you need to make your system 100% available is not just worth the cost of it, right? So most of the companies target a particular availability metric, which could be four nines, five nines, three nines, depending upon their use case. And on that basis, you ensure that you are meeting that availability scenarios for your system. Next is latency. So latency, when we talk about latency, is that, let's say, how much time your request was not served. That is basically what latency is, right? But it is normally confused with the turnaround time. But in normal language, if I talk about, right, in industry, what normally people talk about latency is, let's say, if I have some request that I send to your server, in how much time I am getting the response back. That is what defines the latency of your system, right? Now, your latencies should be as low as possible. That is kind of obvious, right? Because let's say if I'm on a website like Amazon, right? I want to be able to see that detail of that product very fast. I'm not going to, let's say, search for a book and then going to wait for that book forever. I want the results to be pretty quick. So if your systems are not going to be low latent systems, then your systems would not be, good from customer experience standpoint. So if you need good customer experience, you need your system to be low latent systems completely. Okay. Next is throughput. So throughput is basically defined as, how much task a particular node can do, right? So let's say if I have one instance, one node, and that node can process 100 requests in 1 second, right? At some CPU utilization, that becomes a throughput. Okay. So let's say I say that at 70% CPU utilization, my node, my service, one node can, perform 100 TPS. So this becomes a throughput. Okay. For B2C, throughput can be defined like this. B2C is basically business to consumer, direct to consumer, where you're more customer facing metrics. But let's say for some of the metrics where you have, more data churned kind of metrics, right? There, maybe you will define your throughput in more terms of amount of data that you churn per second, right? So for example, then your throughput could be in terms of, let's say, kbps or mbps. Let's say if you say that my throughput of this service is 10 kbps at 70% CPU. So it basically means that when your system was running at 70% CPU utilization, you were able to churn down 10 kbs of data in each second, right? And this is one node. How does this help, right? Let's say if you know the throughput of your system very well, right? You would know that for what scale, how many nodes do you need, correct? So let's say if your system has 10 kbps throughput, and you know that or let me talk more about in tps, because that is what most of the people understand well. So let's say if your system can have 100 tps of throughput, and you need to support a scale of 1000 tps, then maybe you will have just 10 nodes, right? Because all 10 nodes should be able to scale easily to get you 1000 tps kind of a traffic, right? So that is why throughput becomes very important of your system as a metric to understand how much do you need to scale for this particular system. Next is redundancy, right? So what redundancy is? Redundancy basically means that you should be able to replicate your data. There should be no data loss. Let's say if one of my instance of DB goes down or anything, right? My data should not get lost. I should be able to get that data back, right? Like, because if you see a lot of companies that we have now, a lot of systems that we have now are completely data driven systems, right? Data has become the most important thing ever, right? So you cannot afford to lose your data. Okay. So redundancy becomes very important there. Like, how would you kind of make your data redundant? How would you make sure that you're storing, your data at multiple places? This is another feature of your system that you would like to have. Consistency. So consistency is actually two ways, right? When you talk about in databases terminology of consistency, it basically means that your invariants of your systems are completely taken care of. Okay. What do I mean by invariance of a system? Let me just explain this part. So let's say if A is giving some 100 rupees to B, then the balance of A should have A minus 100, and the balance of B would have some B plus 100, right? Now, in this case, the invariants are kind of made sure. Why? Because the total amount of the balance of A and B is still going to be the same, right? Which is going to be A plus B. This is what consistency means in DB kind of fundamentals, where when we talk about databases, this is what consistency means. Whereas in distributed systems, consistency basically means, so let's say I have some data that I have kept it on one node. Let's say this is node. So when I talk about node is nothing but a server. Okay, it's just another server is basically node in distributed systems terminology. Okay, so let's say if I ask, if I set some value of x is equal to 5 on this particular node, right? I should be able to, when I go to read x, right? I should be able to get back x is equal to 5 as the value and not the old value. Now, when does it happen? It happens in the case when you have multiple nodes in a distributed system, right? So let's say you have x is equal to 4 here initially. Okay. Here you went ahead and you are going to write from here x is equal to 5. Okay. So your system should be made in such a fashion, if you want to make it a consistent system, that let's say if I'm going to write into my x is equal to 5 here, then even if I go to read from here, I should get the correct value of x is equal to 5. Okay. That is what your good consistent system would be like. Here, I would also like to talk about the famous cap theorem, because I think that is very important when you understand the distributed system concepts, right? So let's say, oh, sorry. Yeah. Okay. Let's say these are the three nodes that we have. Okay. And the value is 4 here, the value is 4 here, and the value is 4 here. Okay. Let's say all of them are connected to each other via wires and everything, right? And the wires are working fine, the systems are working pretty fine, and everything is good. Okay. Now, and we have a strategy, let's say, where this node is the leader node, or don't worry about what leader is. Let's say this node is one node which will accept the writes, and then it will tell all the other nodes to asynchronously to write that value. Okay. And then only it will give you the information that this write is successful. Okay. So what is going to happen is that I am going to, let's say, write x is equal to 5 over here. So what it will do is it will make it 5 first. Then it will tell to this node that make the x value of 5. It will also make it 5, and it will also make it 5, right? In this case, all of these were working, and now since everything is working fine, so it will just return back you the value of that your write is correct. Now, whenever any read happens, let's say if a read happened from here, here, or here, you will always get the value of x is equal to 5, right? Because all of them have the latest values, so you will always get the value of x is equal to 5. Everything works here, right? Not a problem. Your system is highly available, your system is highly consistent, everything works, right? Now let's see another situation. Okay, so let's say we have x is equal to 4, we have x is equal to 4, we have x is equal to 4, and there is some problem. Okay, this node is down. When I say this node is down, it could be, let's say, because this node is really down, or it could be because, let's say, some wire, there is some wire problem, or there's some power loss, or there's something, right? But this node has gone down for some reasons, it is not pingable. Okay, now when the client says make x is equal to 5, it will say, okay, let me make x is equal to 5 here. It will also tell this that make x is equal to 5. Now here it will have two choices, right? Where it will also try to say to this node that make x is equal to 5, right? But since those node is not reachable, this node has now two options. What are those options? One, fail the write. Why? Because you say that since my x is equal to 5 is not replicated on the third node, I will just fail my write. That is one option. Another is I will say make the write successful. Okay, either the write is successful or the write is failure, right? Now, if you are choosing that you're going to fail your write, then basically you are saying that your availability would go down, but your consistency would go up. Why? Because since now, let's say if you're going to fail this write, you're going to roll back the values here from x is equal to 5 to x is equal to 4, and and next time when somebody comes up and read these values again, you will get back the 4 value. So consistency is high, availability is low. But let's say if you say that make this right, then the problem is that, let's say, according to you the right is successful, right? X is 5. So if you're going to read it from here, you're going to read it from if let's say if some client reads it from here, he will read 5. But let's say when this node comes up, it will have the value 4 only, correct? Because nobody has told it till now the value is 5. So there is a possibility that when somebody reads from here now, you read a value of 4, right? Which is not consistent. Why? Because as per you, the value should have been 5 because you have already written to that, right? And you had read 5 earlier. But from this replica, the value that you're returning is 4, correct? Which is not the correct value, right? So this kinds of says that you're making your availability higher, but you're losing your consistency here. Okay. Now, at some point of time, this node will come to know that this node is up now, right? And it will tell that, hey man, you kind of left x is equal to 5. He will put it down, right? He will update this. And then later on, when you read it from here, you will also get 5. Since this consistency, if you see, right, is getting eventually, we called it eventual consistency, where we say that the system would not be strongly consistent at that certain point of time, but eventually your system would get consistent. Okay, that is why this is called as eventual consistency. Also, let's talk about what the cap theorem is right here itself. So cap theorem basically says that when your network is partitioned, for example in this case, right, your network is partitioned, you can either choose availability or you can choose consistency. You cannot choose both, right? In a lot of people actually tell that you can choose any 2 out of 3, right? Which is pick 2 out of a 3 kind of a thing, which is partition tolerance and availability and consistency, right? That is actually not true. Cap theorem says when the network is partitioned, you can either choose availability or you can choose consistency. Cool. So next, let's move to the expectations from the interviewee. The expectation from interview is that A lot of people actually fundamentally, a lot of people actually also kind of have this doubt, right? Should I know everything about everything? Like, how much depth should I cover? How much breadth should I cover? And a lot of questions around that. So there's one thing, right? Breadth is very important part of your system design, right? Because you should know what all components would you need. You should know that, what those components are, where they are used, how do they plug in the system and everything, right? You should know that. From depth standpoint, there are few components that you should have a great depth of as well, right? For example, let's say if somebody asks on databases, you must be able to tell most of the things if you're a backend engineer, right? But let's say if somebody is asking on load balancers, you can still say that, okay, I've not worked on the load cell balancer side of the layer, and so I don't know a lot about it. But at least at one or two areas where I think you should actually have a great depth on. So you should focus on breadth first and then go on depth later on. So for middle level kind of engineers, I would say that breadth becomes important. But as you go senior and senior, along with breadth, your depth also becomes kindly very, like, it becomes very important, right? Like, depth of that technology becomes very important. When you say databases, you should know how storage works, how you should know how indexing works, you should know how replication works and what database and everything, right? That becomes very important with very senior engineers. But for most of the middle engineers, breadth is what you should basically know. Okay, now in terms of the expectations, a lot of people think that the interviewer is going to drive this conversation, and that is not true, right? The interviewer is just going to give you this question, let's say, which could be design uber, right? A lot of interviewers would also give you some functional requirements with it, but a lot of them does not, right? And it's okay, because they want you to completely figure out at what all these requirements would be that you are going to work on. So you need to drive this conversation. It's very important that you are able to drive this conversation, figure out what you want to do, and how do you want to structure the whole interview. So you kind of take the interview forward and not the interviewer. Don't expect him to take that interview forward. You have to take this interview forward. Now, once you have a completely vague problem statement, you need to move to a viable solution, right? You need to have some basic solution of how this whole thing would work correctly. Then you should also know your trade-offs. You should know that what solutions you had, what all approaches you had, and you should tell that I am choosing this because of this reasons, right? You should have very clear justification. It should not be just out of gut, right? It should not be that SQL makes more sense, right? Why? You should be able to, explain why do you say that SQL makes more sense here, right? All of these are very important. It should be your design, obviously. Like, it cannot be half yours and half the interviewers, right? That does not work. A lot of people, are going to reject you if you're going to, you know, um, make the system design just using the interviewer's knowledge and not applying your fundamental aspects of it. Try to cover both breadth and depth. We have already talked about. For middle engineers, a lot of breadth is important. For a lot of senior engineers, depth is equally important. But even in middle engineer interviews, the people would go into depth of one or two things, right? For example, if let's say if people see that you worked on MySQL, they could ask questions related to MySQL, right? A lot of these things could happen. So you need to cover both breadth and depth. A reasonable depth, but a good breadth is what is more important. Get signal on both your technical and communication skills, very important, right? Because communication, since you're going to drive this conversation, communication skills become very important, right? In coding interview, communication skills are important, but they're not as much important. Why? Because once you've explained the problem, you can just go on and code it up, right? And if your code works, you're good, right? But in system design interview, communication skills are very important. Why? Because until and unless you're able to figure out the way to communicate and explain him the choices that you make, the trade-offs that you take, and your decisions that you make, the this interview would not really be in favor of you, right? So it is very important to have good communication skills. It is also important to have good technical skills, because otherwise you would not be able to figure out how to solve the system, how to solve this problem completely from all the components perspective. So that is also very important. Okay, these are some few common mistakes that I normally see in system design interviews, right? I've been taking system design interviews for a lot of time now, right? I've taken almost 100 plus. So these are some of those common mistakes that I have seen people committing in system design interviews. A lot of time I see that people expect seen questions in an interview, right? Which, let's say, you must have seen on a YouTube, or which you must have seen on a book, or some on a blog or something, right? A lot of people actually expect that, which is wrong, right? A lot of times you can be lucky when you get some scene question in the interview, but some of times you will not, right? And the problem with that is that a lot of times people are not able to figure out, when they see an unknown question, how to go about solving it, right? In coding problems also it happens a lot, where people expect the questions that they have solved, and when a new question comes altogether in an interview, they they're not able to do that, right? So this is very important, that you should not expect that, right? If it comes, great luck. But if it does not, that should still be okay. You should still have confidence on your fundamentals, and you should still be able to make that system correctly. Looking into the problem from deeper level, okay. So what happens is, when you try to overanalyze the problem, right, you end up complicating it. And this has happened with a lot of people, right? So for example, what happens is that, let's say, if somebody is giving you functional requirements, right, stick to those. It is very important that you're going to just stick to those functional requirements. You don't need to, look at all the other requirements, because it is just a 45-minute discussion. You cannot solve for all the use cases, right? You need not optimize from the first design itself. You can make first a viable design, and then maybe optimize on top of it, right? Because it is very important to complete the question, right? And we'll talk about it when we talk about in time management. But it is important to understand that you have some functional requirements to be given, and you have to kind of stick to those functional requirements and solve those particular features only. Trying to fit known design patterns, again, when you've seen this question, what happens is that, let's say, for everything, the candidates will use the same pattern, or similar kind of thing, right? The problem with this is, you need to understand that whatever works for one system may not work for another system. This is very important to understand. So system by system, you should try to figure out that what works, what does not. It is very important. Not clear on fundamentals, obviously. If you're not going to clear on fundamentals, people will grill you down on fundamentals in interviews. So if you're not clear on fundamentals, so that is going to be a problematic thing. You should not move into a territory where you think that your fundamentals are lacking, or you should at least prepare for them, right? That is what I normally see. Like, for example, when I talk about, where do you need synchronous versus where do you need asynchronous, where do you will use SQL versus no SQL, right? A lot of these questions, people are not really clear on what fundamentals that they should use. So you can actually have some understanding about it before you're going for an interview, to understand the fundamentals behind any of these things that you're saying, and to be sure that you're getting them right in your interviews. Using fancy terms, again, if you are going to use, say, things like Kafka or Redis, right, then it is very important to understand that people can ask questions like that. So you should be able to explain them correctly, right? So your fancy terms, if you don't know them, just don't use them. Okay, it's very important. You should not use fancy terms if you don't know them well. Lack of confidence, again, that is very important. If you have good confidence, because you need confidence in order to justify your choices, in order to justify your uh, you know approaches that you're taking, right? You need to be able to decide what you're doing, right? So it is very important that you are confident when somebody gets an unknown system design problem. Time management, again, very important. 45 minutes, you have to do that, right? So if you're not going to manage your time very well, then you would end up leaving few things here and there, which is going to be a red flag in an interview process. And random order, we'll discuss about this random order in great detail for the rest of this webinar, right, where I'll talk about what is a good order in which you should approach a system design problem. Okay, so random order or chaotic approach is this. I have given you a problem. Let's say the interviewer gives you a problem and you start on the solutioning without actually thinking about the functional requirements or the non-functional requirements. You just move to the solution, and then you, let's say, start with API endpoint, and then you, let's say, start with the DB schema, and then you are coming back, and then you are trying to answer that for which schema, what kind of DB I am going to ensure, like what kind of DB I'm going to store it, right? So when you're not following a particular structured problem, structured way of solving this problem, that approach would be chaotic, right? Because it is going to be problematic for you as well as the interviewer. Why? Because interviewer will have to track a lot of things, and for you also it would be problematic because you will easily miss on a lot of these things, right? For example, let's say if you talk about DB initially and you did not clarify on the functional requirements, and when somebody came up with some new requirement, you would not be able to, let's say, inculcate it in your approach. So that is a problem, and that is the problem with chaotic approach as well. Another problem with chaotic approach is that it's very difficult to do time management there, right? Because when you go for chaotic approach, time management is very difficult. You yourself like can't track your time, right, easily, in which part you're spending a lot of time, in which part you're kind of spending less time. That all you kind of you kind of lose track of. So that is why chaotic approach is another problem. What we'll talk about is systematic approach. Okay, so this, now what we'll talk about is the general framework, how you should actually approach your system design interview using this framework. And what we'll do is we'll take a system design problem, and then we'll try to solve, we'll try to see how does this system design problem fit into this particular general framework. Okay, that is what we'll do. So there are 7 steps of the general framework. One is the requirement analysis. So let's say once somebody gives you a problem like design Uber, right? You should be able to do the requirement analysis of this, right? Like, what all features do I need to support? Okay. What is the scale at which I need to support? Because a system for, let's say, 100 TPS would be very different from a scale, from a system at 10,000 TPS would be very different from a system, let's say, at million TPS, right? So you need to be able to understand that for what kind of scale you are making the system, for what requirements are you making the system, or do you need more consistency here, or do you need more availability here, right? All of these become very important when you are doing a requirement analysis of your systems. Next is defining data models, right? Once you have your requirements clear, you should be able to define your data models. How would your data model look like, right? How would your uh, backend entities look like? What would be the relationships that you would keep between your data models, right? These are very important. Then comes your back of the envelope calculations or estimations, right? So once you have a data model, you should also know that how much data are you going to store, okay, or how much TPS would you need, how much scale would you need. All of that information should come up in your estimations, where you try to estimate that, how would I store this data. Let's say if it is going to be terabytes of data, then there could be different systems for storing that data. Let's say if there is going to be MBs of data, then maybe you can just store it in memory itself, right? Things like that could happen. So a lot of times it is very important to understand that how are you going to estimate this data, and then figure out how are you going to store this data, or at what scale are you solving this problem for. So all of these becomes very important in an actual system design interview. Then designing system interfaces. Now, once you have all of this done, then you should design your interfaces for it first. When I talk about API, like interfaces, we are talking mainly about APIs as well, right? Where we are talking about, like, how would the user interact with your system? What API would that be? What endpoint would that be? Right? All of this becomes very important when you are going to make your system working end to end. Then you should come to a high level design, where you should tell what all components would be there, uh, what all things would you need, and all of that stuff. Then you should go for detailed designs for component by component, where, let's say, if you have 2 microservices, then you should talk about each microservice in bit depth, where you talk about what this microservice does, how does it, how does these two microservices talk to each other, or things like that. And then the last part is where you should be actually trying to figure out what are your bottlenecks, what are your failure points, what are the optimizations needed, and then you should be working on resolving those particular bottlenecks and your things for that. Okay, so for requirement analysis, your general question should be this, right? What is the scale? What is do I need more availability? Do I need more consistency? Who is this customer, right? That we are making for, because for different kind of customer personas, you could have different kind of systems made, right? Let's say for seller in Amazon, the system would be a bit different, but for customer, like the end user, the system would be much different. For an admin kind of a persona, the system would be a bit different, right? So that is why requirement analysis is very, like, knowing your customer is very important in a requirement analysis. Then how much latency can you do? What are the type of client interfaces? Is it only mobile? Is it both web and mobile, or how is it, right? What is the user growth rate? Are there any legal obligations or things like that, right? So for example, one legal obligation could be that you cannot store this data for more than 30 days. Kind of a legal obligation could be there, right? So these are just some examples of, what generic questions of requirement analysis that you can ask to your interviewer. Okay. So another thing that is very important is that, let's say many of questions are very open-ended and vague, right? Let's say design Facebook. Then you should need to first clarify the scope of it, which basically means that which part of Facebook do you want? Do you want me to design the newsfeed? Do you want me to design the recommendations? Do you want me to design the messenger? What do you want me to design? And then let's say if somebody says, if the interviewer tells you, okay, I want to design the newsfeed, then you should ask more questions on the newsfeed part, right? Where what all functionalities do you want me to support on newsfeed, right? Do we need to support the real-time updates? Do we support only text, or do we support photos and videos as well? Do we support commenting? Do we support likes, or do we support all the 6 reactions that Facebook has right now, right? All of these questions are very important to be, so that you can scope down this problem to a lot, and then try to understand that how would you solve this problem correctly. Okay. Okay, so another point is that you should not floodgate features. Okay, when I say floodgate features, there are a lot of features in our app when you actually talk about it, right? But you should not talk all of those features. You just need to first figure out what is the minimum viable product of this particular um, system is, right? And you should just try to design that. Until and unless the interviewer himself or herself wants you to focus on some other feature. Okay. But then you should have that clarification very early in an interview to understand what you're going to design, right? So don't floodgate your features. Mentioning too many features is of no use until unless you're going to design correctly for them, right? Secondly is throughputs, right? Like how what kind of throughput do they want from your system, or what kind of scale do they want you to support, right? What is the expected read and write ratio? How will the user interact with the system? What are the inputs and outputs of the user and everything? All of these things are very important. Assumptions need to be stated very well. A lot of people assume things, but they don't state to the interviewer, and that is where the whole problem lies. Why? Because people are not able to, when you don't call out your assumptions, the interviewer would not understand it. So let's say if you don't call out that I am assuming that my scale would be 100 TPS, and you're designing designing a system according to 100 TPS, right? How would the interviewer know about it, right? This is going to cause problems for you. Why? Because he or she may expect the system to be more optimized, right? Because in his mind, the scale could be 1 million TPS. But since you have not assumed it, called out your assumption, you have not confirmed with the interviewer, these things are going to cause problems lot later in the interview. And when it start causing problems in the lot later in the interview, there is already too much time which is spent, right? Which then gets a problem. Then when you've spent a lot of time in a wrong design, in a wrong path altogether, then there is a problem always, right? Because it becomes very difficult for you to come back in for the next 45-minute kind of an interview. It becomes very difficult. Okay, so what we'll do is we'll just make some take a design problem today, and then we will see for all these structures that we are talking about, all the general structure that we're talking about, how do we use them in this design problem today. So let's say you're a technical architect in a big car company, and the company is launching an IoT based health monitoring system for the car. Okay, so health monitoring system would basically mean that what is the health of this car. Okay, basically I want to answer this question, right? That what is the health of this car. Now, if you think about it, right, the first question that should come to your mind is, how do you define health of the car? Okay, so let's say what the health is, right? Do you define it on the basis of its fuel efficiency? Do you design t- tell it on the basis of its engine efficiency, or other things like that, right? How do you define that? How health, like what is the health of this car, right? So those questions you need to ask your interviewer. Other questions that you can ask is, what could be the user base, right? How much? So here I've just taken few examples, right? I've just taken, let's say, 10 million is the user base. Another question is, how frequently would the event update happen, right? Because since it's in your car is an IoT, like it's an IoT based monitoring system, right? So your car is going to send this data to the server, right? So what is that frequency of the event update? How to show this data? How will you show this data? How frequently will you show this data? What sensors to account for initially, right? This is what I meant when I talked about the health monitoring system, right? That what sensors are you going to account for initially? How to show this data? Is it going to be a notification system based, or is it going to be a pull based kind of a system? Notification is mostly on the push side of things, where the server itself sends you a report, let's say daily or monthly or weekly, whatever it is, right? And it tells you that there is a problem, or your machine is fine, or things like that. Pull based is, let's say you have given me an URL, and I can anytime go and check on that URL that what is the health of my car is, right? So how do you want me to show this data? And then, does this data need to be consistent, or does this data need to be more available? So if you think about, right, consistency is not a very big importance here, right? But availability is actually very important here. Why? Because I want to be able to check that what is my health monitoring, like what is my health of the car, even if it's, let's say, slightly delayed or something, right? But if so, availability would always win in such cases. Let's talk about data models now. Okay. So, what is data modeling? Let's just first understand this. Data modeling is the way to organize some data so that you're able to respond to the request which are served to your system. Okay. So, how then how should you actually go about thinking it? The first thing that you should think about when you're talking about data models is, what is your query pattern? Okay, what kind of queries you need to answer. That is from where you will be able to understand how should your data model look like. A lot of times what people do is they make some data model on their general understanding, but then they don't check whether I can query all of them or not, right? I am able to return all the responses for the all type of queries that I need to do on this particular data model, right? So you need to understand that this should be actually derived from your query pattern. What kind of query pattern do you have? And then you should make your data models. Then other things that you should look forward is, what is the read write ratio, right? Is your data to kind of more going to read more, or is it going to be written more? So in this case, for example, the data would be more write heavy kind of a system, right? Because we are going to update it every minute, update the data every minute, right? Then is some part of data query too frequent? If that is happening, caching should basically come into your mind, because caching is an optimization that can give you. So how does caching help is that it is an in-memory data store, right? So when you have in-memory data store, you don't have to go to disk for querying the data. And disk reads are way slower than in-memory reads. Okay. So the point is that you will be able to also give this response in timely fashion to the customer. And also you will be able to save some load on your DB, right? Because if this data is getting queried too frequent, then your request would not hit database so many times, so you would be able to manage load there as well, and you would also be able to make the latency of this data pretty less when you use caching. Next is that you should identify the major entities of the system, right? Like what all entities of the system are. So let's say in a library management system kind of a problem, the entities of the system would be, let's say, books, users, right? Or let's say, there could be other entities as well, depending upon what function requirements do we have. But books and users are kind of pretty much obvious entities of that particular system, right? So like this, you should identify for any system what are the major entities, and then you should model them. Apart from this, you should also understand that if you're going to store things like photos, blogs, videos, or anything, right, then you may need things like a different storage engine like S3, for example, right? So you should be able to figure out all of that, like whether this DB is good enough for this, or do I need to be storing this information in some other storage engine. Another problem that a lot of times you will face when you're designing a data model would be that should I use SQL versus should I use NoSQL, right? So I'll just give few things here, okay? But we'll talk a lot in detail in SQL versus NoSQL as well, right? So whenever you have a strong consistency requirement, SQL is the way to go, okay? Because we know that SQL has given strong consistencies across, right? Because they have invariants in place, they have asset properties, and so strong consistencies are always a SQL way to go. Okay. For variable schema, no SQL makes a lot of sense. So let's say when you have a schema that is quite changing, okay, that is when your NoSQL makes sense. Yeah, in that case, because all the table commands as well, because see, there are two things of this. One thing could have a variable schema, one thing could have a fixed schema side of things, okay? So let's say when I talk about a book, or let's say when I talk about a book, it could have fixed side of things, right? Where I would have, let's say, book ID, book name, author name. I could have things like genre, I could have things like a lot of other things, right? But when I talk about data like, let's say, log data, right, it could have a very well variable schema, right? Because in one application log, you may get some other schema, and in another application log, you may get some other schema. Or JSON, for example, if I talk about, it's not your JSON is not strict rigid schema, right? It is very flexible. You can very well go and add a new column, add a new key in JSON, right? You can remove a key whenever you want. So for all of these requirements, NoSQL make a better choice. Horizontal data distribution requirement. So now let's first understand why do we need to distribute this data horizontally. Okay, let's say I have one node which has 1 terabytes of disk. Let's just assume this for now. Okay, now your data is going to be beyond 1 terabyte. Okay, there are multiple ways. Now there are two ways of basically taking care of this, right? One is I add more disk to this particular node itself. So I replace that 1 TB disk with 2 TB disk, or with 3 TB disk, or with 4 TB disk, whatever it is, right? This is what is called as vertical scaling. The problem with this is that there is some ceiling to it, okay? Because at some point of time, you will hit that ceiling. Because let's say there would be no hard disk which is like, there would be no hard disk of 10 TB. I'm just making up these numbers, but I'm just saying this, right? You should understand the fact that there would come out to be some ceiling where you would say that, okay, the 10 TB hard disk does not exist, or it is so costly that it is of no point. Other ways of doing this would be, I can have, let's say, for 3 TB data, I will have 3 nodes. Each node has 1 TB hard disk. This is called as horizontal scaling. Okay, so this is what I do is, instead of making all the data in the 3 TB hard disk, I split that data into 1 TB, 1 TB, and 1 TB. Now for NoSQL, why people say that NoSQL are horizontally scalable? because most of the NoSQL databases have out of the box support for this kind of thing. Okay, where you can create partitions and you can put these partitions on different machine and then use them however you want to do them, right? Most of the SQL databases don't come with that inbox in, like, most of the SQL databases don't have that out of the box support. That is a problem. But this does not mean that SQL databases are not shardable. They can be partitioned, they can be sharded. Okay, sharding and partitioning are kind of synonymous, right? So, like, don't get confused with the terminology. But the point is that both of these are technically, SQL data is also shardable. Okay, it's just that you don't have an out of the box solution for that. There are tools like Vitess, there are systems like Vitess which help you kind of shard your SQL databases. But again, you will have to take care of it, you will have to employ it, and you will have to deploy it in your system and then take care of everything. So that is a pain point, right? Whereas in NoSQL case, it is out of the box, so you don't have to worry about a lot of these things. And then for a lot of times, for event capture, for analytical data, NoSQL makes a lot of sense just because the volume of data that we have. Okay, so let's say about our the data model for this particular problem that we were talking about, right? So if we talk about read to write ratio, we see that read is pretty low. Why? Because as I mentioned, right, we are going to write every minute for that car, right? And when you think about for all the cars, the for the number of cars which was 10 million that we took earlier, right? The number of writes happening per second would be way higher than reads. So when you get this, you kind of understand, okay, that I need to go for a database which is more write optimized, right? And so this becomes one choice of how you should choose your DB. Okay, then you need to figure out, okay, that UI can be on minute or day basis, right? That you must have already clarified with your uh, interviewer, right? And so you can keep your pre-computed data correct on the day hour basis, and you can cache that data for those things if you need it, right? So a lot of these things would come upon your query pattern, right? Like what data you need, do and I have just written here cached, but it is also possible that the interviewer says that we don't want to query this data again, we just want the real time monitoring. Then maybe you don't need to cache it, you just keep this data and then you're going to purge it off after 30 days or something because of some compliance or something, right? So that is why it is very important to understand that once your requirement analysis is over, your data model follows your requirement analysis completely. So here I have taken, vehicle ID attribute value and timestamp as this. So where vehicle ID would be your vehicle ID attribute would be your the actual attribute, which could be, let's say, you know, uh, the fuel efficiency could be one attribute, right? The engine efficiency could be another, or there could be other things, right? Whatever it is. So those things could become your attribute. Their values could become their actual values, and the timestamp is basically when did you record this kind of an information, right? So this is a pretty basic kind of a thing, but which model should we go with? So given that we have a huge data volume, right? And this is where your estimations would help. We will see in the next part like how estimations would help here. But with your estimations would help that since the data volume is huge, it makes sense to go with NoSQL here maybe, right? Because the data volume is huge, we can easily partition the data by vehicle ID, and then I can have an index on timestamp because I want to query on timestamp basis, right? So I can have an indexing on timestamp, but I can partition all of this data by vehicle ID. Okay, and it could be anything, right? For example, I can have an hash based indexing or a range based indexing, right? um, Hash based indexing is basically when I say that, in fact in partitioning also, is basically when I say that you know the hash key of this particular data is going to be in this particular partition. That is what is basically hash key partitioning. And range key is basically when I say that, let's say we are partitioning by vehicle id, and vehicle id is an integer number, as an integer, right? So I say that all the vehicle ids from 1 to 10,000 would lie in this particular instance, all the vehicle IDs from 10,000 to 20,000 would lie in second instance, and so on. This is all range key partitioning then. Okay, now let's come to the back of envelope estimations, right? So since we have the data models, right, we should know that what your system storage should be. Throughput, basically a lot of people actually use throughput in scaling, the scaling semantics in, completely replaceably, right? So I've used throughput, but scaling is actually a better term here. So through that, you can drive that based on the amount of scalarity, right? Like for every concurrent users, if you have 100 users in each second at one time, then it basically you can figure out that how many people are going to concurrently use the system, how many requests you're going to get per second. Those kind of things are important. Network bandwidth could be in terms of bytes per second, that like how much network bandwidth do you need and everything. And then you can also ask about archiving strategy, which is, do you need hot storage for this, do you need cold storage for this? Now what is hot and cold storage basically meaning is that, you know hot is, let's say, cache is basically a hot storage, right? Cold storage could be archival. So hot and cold basically mean that, you know now, but when I talk about archiving, hot storage would, let's say, be meaning a S3 standard storage class, right? Which basically would mean that I am going to pay more for it, right? I am going to, put data and I am going to query frequently over it, right? That's a hot storage. Cold storage, whereas, is that you're not going to query this data much, right? You're going to pay only on when you're querying this data. You're just storing this for some reasons, maybe for compliance or maybe for some other reasons, but you're not going to query this data much. That is what is basically meant by cold storage. And then there are federated queries. Federated queries basically means that how are you going to, divide your queries and make queries over this hot storage and cold storage, and, you know able to be divided into your whole system into federated services, which is completely different from microservices and should be able to query across multiple data stores and things like that. So, for example, in this case, I can say that vehicle ID is 4 bytes, attribute is 10 bytes, value is 4 bytes, timestamp is 8 bytes. You can do whatever you want, right? And like this, you can come up and say that for one row, I'm going to have 0.25 GB per minute, and this would translate to 160 terabytes data per year, right? So that is how we can do this. Similarly, I figured out some throughput, and I figured out that, how much uh, my machine would handle, how much machines I would need, and everything. But again, these are all uh, with assumptions, right? You don't know that whether your system would actually handle 5,000 requests per second. Okay. They can only be reduced when you perform a extensive load test and figure out that how much your one node or would be able to serve, right? So this could be very different, but this is just an assumption that you can just call it out. Similarly for network bandwidth, right? Now, another problem that I want to actually talk about is that a lot of people actually just talk about 1 year data, and then they don't talk about the rest of it. The thing to understand is that it is equally important to understand that how your user growth would look like, right? You are not making the system for next 1 year. You are making the system for next 3 years or 5 years, right? There is some time limit that you need to at least make sure that your system is scalable up to. So if you want to go with 3 years, call it out and tell that for these 3 years, I would need this much data, right? And then I will use this calculation. So for example, when we figure out that we need 160 terabytes per year, right? So this basically means that we need a lot of data, right? And we cannot store this data in one hard disk. And that is why we move for a NoSQL kind of a solution, right? So even this is helping you decide, because you want your data to be partitioned and you don't want to take care of all of that, uh, you know, problems that you will have to deal with in maintaining your own bits and everything. So you go to a NoSQL DB, and that's a perfectly valid justification for choosing NoSQL over SQL in such cases. Okay, next is the system interfaces. When we talk about system interfaces, we are talking about the APIs basically, right? You should write the correct APIs, right? For example, here I've given examples in terms of, let's say when I'm putting it, I'm writing it's a post measurement and what all data do I need in body. And similarly in aggregate data, I'm giving some query params and whatever criteria I need. But the point is that your APIs should be correct. They should be REST compliant if you're designing REST APIs, and make sure that your APIs do what they mean, right? That is actually very important. Uh, when you're talking about system interfaces, it should be very clean in those terms. Okay, high level design. High level design is basically this thing. Okay, that you should identify the major components of the system first, right? What all components do you need for the system? Draw these components and their interactions. How do these components interact with each other is very important. It could be via HTTP call, it could be via queue, it could be via anything, right? But you should be able to understand that how do these components interact with each other, and you should be able to explain that as well to your interviewer. Make sure that HLD fits into a single page. This is not a actual requirement, to be very honest. I have written this just because a lot of times when you have, multiple, you have your HLD spanning through multiple areas or things like that, a lot of people get confused with it, right? So make sure that if you're writing so many, like if you have too many components to draw, maybe just draw them with a lower font, right? So that you're able to fit a lot of them into a single page, so that it is easier for the interviewer as well as for you to be able to justify that the HLD is correct. And for the interviewer also, it would become very easy to understand that this HLD works end to end correctly for all the use cases that he has mentioned. So, for example, in this case, this is one of the HLD that we can design, where we have clients, we have a gateway, we have a load balancer, we have application servers, which are horizontally scalable, right? So, one way of actually making application server horizontally scalable is this, right? You don't have to design three boxes to show that your system is horizontally scalable, right? You can say that this is my application server, which is horizontally scalable. This is one way of representing it. Then you will have data stores, which is your DB. Now you get to the detail design. Okay. When you go to detail design, this is mostly, the interviewer. Now, this is where part the interviewer will kind of ask you, okay, that let's say he'll say that, okay, I understand that for booking, you would need payments and you would need, let's say if I talk about flight booking, you would need some flights, you would need some booking service, you would need some flight service, all of this, right? But I want to really understand about how are you making this booking, right? How does your booking service works in particular? Okay, then maybe you will have to go into the depth of your booking service and explain him correctly or her correctly that how does this booking service works, right? People can also go into your DB, for example. If you say that I'm going to use MySQL, okay, then what data will you index your query on? Like, what will you index? What will you not? What will be your constraints? A lot of these questions could be asked, right? So you should be able to explain anything that you have written on all the components that you have written. And then you should be also able to explain the thought process behind that decisions that you have taken, right? Those are very important when we talk about it in when we go in depth. Again, justifying of decision is very important, that we have already talked about multiple times. And this is the last thing, where what we'll do is we'll try to identify the bottlenecks and then we'll try to resolve them. What are the famous, what are the very important bottlenecks that people kind of miss? Make sure that your systems does not have single point of failures, right? How to you have to make sure that your system does not have single point of failures. Make your systems redundant, right? Make sure that you're not running just one application server, even though it can handle alone itself, right? Let's say if your system TPS is only 5, right, then maybe one system, one node will handle it. But don't let it be the single point of failure, because if it goes down, then your whole system goes down, right? So make sure that you're not getting any single point of failures. You need to figure out the components which can't scale beyond a certain point. Okay, that what are the components which you cannot scale beyond a certain point? For example, let's say if you are using one SQL instance itself, right, the for your service, then it cannot scale beyond a certain point, right? And it's okay. Let's say if that is coming up after 4 years or 5 years, it's okay, right? You can redesign at that point of time. But if it is going to come in, let's say, within 6 months, then it's not a really good design. Why? Because you will have to redesign your system in next 6 months, and no company actually wants to rework things again and again, right? So that is why you should not you should try to figure out at what are the components which can't scale. You should try to figure out at what how I can optimize a lot of these things, right? So for example, you should understand that what all data can be cached, right? That is one optimization. There could be other optimizations as well, right? In your code itself, there could be multiple optimizations that you could do, right? So you should try to understand that what all bottlenecks do you have in your system, and then you should also talk about how will you resolve those bottlenecks. Okay, for example, if you're talking about single point of failures, you would put multiple services behind it, right? You would put multiple things in your like if there is only one DB instance running, maybe have one replica of it always running, right? So that you are able to at least make sure that even if DB instance goes down, you have another DB which is running, which can get you that data, right? So it is always about figuring out all of these things, and sorry, and then resolving them correctly. Next is, you need to consider the non-functional aspects. A lot of people, and believe me when I say this, right, a lot of people actually don't talk about any of the non-functional aspects in an interview, which is very much problematic, right? You should talk about availability, fault tolerance, failure, recovery, whatever you know about, right, in an interview, so that you kind of tell the interviewer that I am going to consider all of this as well when I am going to design my actual system, right? This is very important, because a lot of people would just go and solve the problem, but then they will not talk about a lot of these things, and the interviewer would assume that he does not take care of all of this when he is designing something, which is maybe not correct, because you were taking care of it internally, but you did not call it out. You did not talk about them in detail, and that is why there was a problem. Okay, so some of the examples, what will happen if load balancers fail, right? Because you have, let's say, one load balancer running. What will happen if it fails? What happens if there's a fault at DB layer? Okay, the DB went down. Then can your application perform without it, right? How to cope with situation when there is no network connectivity between client and API gateway? All of these things. And sometimes it's okay to have that answer that, okay, if this is going to happen, my system will go down, and it's okay, right? But that should be a very conscious call. Okay, because as I mentioned, let's say, um, can the application perform if there are faults in DB layer, right? It is tough, right? If you are either you are going to cache all of the data, but that is very over engineered solution at very high cost, right? And maybe it does not make sense for your system, right? Maybe you can actually fail your application, actually say that we are in outage when when there is a when your DB layer gets down. But there could be cases like, let's say, there's some faults in DB layer, and you can maybe handle it, right? So for example, if you've used DynamoDB, then there is some case where you get some throttling exceptions, and then you can just retry it from your application itself, right? So a lot of these things actually matter. Very famous thing to actually take care of your system and to understand in a real world is the chaos testing, right? What happens there is that people deliberately get your system, your components down one by one, and then they try to see if your application works with it being down, right? So let's say if you have multiple microservices, they'll get one microservice down, and they'll check that whether your service can still work without it or not, right? So we should try to make our application as much as possible to work without or despite all of these setbacks. But again, it could be a case where you say that, okay, we have a hard dependency there, and we would not be able to work without this because of this reasons. But again, your reasons should be pretty much justified. You should be able to explain why you take that call, and you should be able to explain that correctly to the interviewer. So yeah, with this, I think I'm done from the general framework side of things, right? I hope that you are kind of you have understood in terms of how should you approach a system design question, right? And how you should actually go about answering it in the structured fashion, where you talk about, from requirement analysis to data models to estimations, and then to your APIs, high level design, and then you can move to your optimizations and a lot of these stuff, right? Cool. So that is, I think, from my side. Sheil, over to you. Let's take some questions. Hey, Sheil, I think you're on mute. I'm sorry. I think you're on mute.
Yeah, so I was saying that we'll pick up some questions from the comment section now, and also there is a form which is pinned from Geeks for Geeks. You can, if you want the slides for this session, the whole PPT, we will email you the slides. Just fill out the form which is pinned here. Uh, okay, so the first question is from Prashant. He's asking, he's in second year, and he's asking how he can get a job in TCS.
Okay, so Prashant, actually, for a since you're just in second year student as of now, right? You don't have to actually worry about system design in terms of interviewing purposes. I think to get a job in a particular company, I would say that you should go and check, what kind of questions does that company ask in the interview process. You can get them easily on Geeks for Geeks, right? And you should then try to understand that how those um, like how should you approach those problems, right? Because as far as I understand, TCS will ask a lot of aptitude based questions, some communication skill side of questions, as well as some coding and technical side of questions as well, right? So then you should if you're practicing for one company, then maybe you should do take a backward approach, where you first figure out what questions does this particular company ask, see some of those interview experiences, and then try to build an understanding of your own, what you should prepare, and then start preparing for it.
Okay, the next question is from Dera, who is asking, uh, do we need to be good at CN, OS or DBMS to be good at system design?
Oh yeah, to be very honest, a bit of it, yes. To be like, I am not saying that you need to be extremely good at it in terms of to understand the whole computer networks, operating systems, or database management systems to be good at system design, but some basic part of it. Because let's say, especially on the DBMS side, why I'm saying so is this. Let's say if you're designing your data models, and if you're talking about your data models, until unless you understand what are the constraints in DBMS, until unless you understand what transactions are, until unless you understand what asset properties are, you would not be able to make a good choice about which DBMS should you use. And also you would not be able to make a you would not also be able to explain to the interviewer, right, that why have you taken the decision, right? Until unless, let's say, and I'll give you an example. Let's say write heavy and read heavy. Okay, there are two indexing mechanisms that are primarily famous, right? One is log structured merge trees, LSM trees. One is B plus trees, right? Until unless you understand how LSM trees works or how B plus trees work, right, and how do they help in indexing, you would not be able to justify that. Why would you use a LSM based LSM based DBMS for write heavy systems, or why would you use B plus T is based DBMSs for another kind of a system, right? So good knowledge is obviously important. In OS case also, you may not need a lot of deep down OS knowledge, but if you understand that OS is the crux of what we do, right? Everything that we're doing, when we talk about that, we are going to use cache, we are going to use RAM, we are going to use hard disk. All of this is actually a part of OS, right? So a basic understanding of all of these are kind of necessary to be able to understand how your whole system would look like. Similarly, for computer networks, maybe you don't need a lot of knowledge on computer networks. You don't need, informations about every layer of OSI and everything, but at least know basics about, what is HTTP, what is HTTPS, or how does this communication happen, which communication is actually synchronous, how can I go for a synchronous communication, how can I go for an asynchronous kind of communication, Or let's say web sockets is another thing that you would kind of need to know from computer network standpoint. So I think that is why you need some basic understanding of computer science fundamentals to be good at system design. I hope that helps.
Yeah, definitely. It will help. There, our next question is from Mohit, who is asking what is the need for no SQL database in system design? Can you please
Oh,
elaborate?
nice. This is actually my favorite question. When to use SQL versus when to use no SQL. Okay, so I'll tell you, right. Let's first try to understand why NoSQL databases actually came into picture, right? There are multiple problems with SQL kind of databases. Okay, when I am talking about, let's say let's take your LinkedIn profile. Okay, your LinkedIn profile has a lot of things. It has your profile picture, it has your name, it has your bio, it has your skills, it has your experience, it has your education, it has your recommendations, a lot of these things, right? And if you come from SQL background, you would understand that you would need a multiple tables just for storing this kind of information, right? Whereas on the UI, you are actually showing the complete profile page in one go, right? So this basically means that on the API side of things, I would need multiple joins to be able to transfer that relational table to your object kind of mapping, right? That is where the ORMs actually came into place, which is object relational mapping, right? For example, Hibernate is one of the most famous ORM in your Java world, right? So this is why ORMs were written, so that a lot of boilerplate code that was written just to convert your relational database to object code is kind of removed off, right? Now, NoSQL databases solve this problem, right? You can store those objects directly into your databases without actually having like both of them, right? You don't have to store the relational data. First of all, model that data into relational data and then store it back to the object kind of data, convert it back to object kind of data, and then show it to UI. That is first thing. Second thing is that a lot of times when your schema is kind of not fixed or not rigid, right? There is very much difficult. It's very difficult to be able to make changes to your data definition layer at SQL World. Why? Because if I'm not sure if you have done this, but if you talk about somebody who has, let's say, millions of entries in a SQL table and they go in and add a column, right? They'll tell you how horror it is, okay? Because it can cause your system downtime. It takes a lot of time to be able to kind of backfill the values for the older data that you have, right? So for flexible schema, things are no, your there is no direct way of modeling your system design, right? If you're talking about a very flexible schema like a JSON schema or something like that, right? You don't have a very flexible way of modeling it. So NoSQL databases also give you that flexibility, right? In terms of how do you want to model it, you can do whatever you want in this. Third is from scaling standpoint. Now, like if you talk about before 2010, right, a lot of these systems, data was not that prevalent in your society, right? A lot of these systems were not on actually computers, right? The real life systems as well as I'm talking about, right? People were not using internet that much, right? So data was not much, data was pretty less. A single instance MySQL would, a single instance Oracle server, SQL server would kind of handle it pretty much correctly, right? With the increasing of data, as you must have seen that with this increase in data, it has become very important to be able to horizontally scale up your database, right? NoSQL databases give you that thing out of the box. And if you see in even in your day life job, you must have seen this, right? That people prefer to have things which are thoroughly tested, which are already being used by multiple people, right? Because if you make the whole sharding strategy yourself and design it and implement it, there are two problems with it. First, it is possible that it has some bugs, which is why it does not work after all of that hard work that you do. And secondly, another problem is that it will take a lot of time, and people don't have time these days, right? The go to market needs to be really slow. It needs to be very fast. You need to hit the market first, otherwise your competitor is going to drain you off from the industry, right? So tech technically is an enabler for business that way. So even in those cases, it makes sense to use NoSQL systems out of the box, where you see that the scale is huge and you can use them directly over SQL databases. That is why there is a need for NoSQL databases in system design.
Okay, so I hope Mohan you got the whole answer, and I think Priyansh has elaborated on this question pretty well. So you may have gotten the answer. Okay, next up is Swapnil. I'll read out the question: How to tackle LLD with Python, given there aren't many OOD things that can be demonstrated during the interview?
Okay, so Swapnil, I'll just tell you two things, right? Don't mix your LLD with a language. Okay, does not matter, right? You should be able to understand what a class is, what an object is, what interfaces would you make, whatever thing, whatever language that you use, you would be able to kind of, you know, use those constructs to make your design correct. So don't worry about using Python, Java, Scala, C++, whatever it is, right? Just think more in terms of what objects would you have, what interfaces do you need, right? What entities do you need your system to be? And then you need to figure out that how your whole system would work as a whole. Okay. So what I normally start with is this: when I'm given an LD problem, I first try to understand that what is my customer, like what is the expectation from this particular system. Okay, which basically translates to what are the APIs, what are the public facing APIs that I need to have with. Once I get those public facing APIs, I need to be able to break down into what all it would need to serve the business logic for this particular API, right? It could have multiple methods down the line, right? Which would need multiple, again, which would need multiple interfaces. So for example, there are, let's say, two types of user. So you may have an interface for user where you have an admin user, you may have a business user, you may have a direct user, things like that, right? So you should think more in terms of domain rather than actually in thinking of terms of language and code. Don't think in those terms. Think more in terms of what domain are you solving this problem for, how are you solving this problem, in terms of what entities do you need, what all layers do you need to be able to like flow this data. So for example, you may have some controller, you may have some delegator, you may have some data access layer, object layer, right? So design that correctly. Make sure you are using the right interfaces wherever possible. Make sure you are using the right enums wherever possible. Make sure that you are also using the correct entities, right? Again, with object oriented design, models are still kind of, if you think about, right, models are again DB schema only. They're nothing other than that. So with, in an LLD interview, people normally take three things that people normally judge for. One is your class diagram, which is how does your class data moves, right? Another is your interfaces. How, what are your public facing API endpoints? Are you able to identify what your public facing API endpoints are, right? That is another very important thing. And third thing is that you should be able to figure out your DB model, which is the DB schema, correctly. If you're able to do that, then these are the three things that you need to demonstrate. So don't say that there are not many OD things. These things people can go on and take in 2 hour interview also, if possible, right? Because then they can ask you to tell how would you implement it. Then people would come to say and tell me how would you do it in a multi-threaded environment. Okay, so a lot of these questions can also come up in LLD world. Yeah.
Okay, the next question is from Vinanti Thakur, who is asking: Instead of high level and detailed design, is it okay to go with single design discussion?
I'm not sure, Vinanti, what do you mean by single design here, though? But when you talk about single design is like single design is roughly high level design, right? Where you're talking about that you will first figure out what the problem is, right? You will first figure out how do you want to approach that problem, and then you are going to design that, like propose a design for that particular problem, and then you should be able to go into some depth of those components that you have made, right? A problem cannot be completed until unless you have some fundamental knowledge about its high level components, and also into some fundamental knowledge about, you know, what components would you need, and also how would you kind of plug them together, right? Let's say if you know that I need databases, if you know that I need caching here, but you don't know that how caching and db should work in sync with each other, then there is also a problem, right? So a single design discussion, if you mean where you say that I'm just going to give one design on one particular system component and not talking about in breadth, that is going to be a problem, because systems don't work in isolation. They work together, right? Caching will work with will work with application layer, application will work with load balancer. Until unless you have load balancers, there is no point of horizontally scaling your dbs until unless there is a way to reach to them, right? So that is why a single design discussion, if you mean it, if you means by a single design discussion that a design discussion on one component, then I don't think that is okay, because that is not going to solve the problem completely for you in the system design interview. So you need to go for a high level design, component by component design, and then maybe go into depth of some of them if needed. That is how I would approach it.
Okay, Samarth is asking, will system design ever be automated? And what is the importance to be good at CP, to be a good system designer?
So no, system design cannot be automated, right? Because it is a thought process. Every system has a different way of approaching the problem, right? Now, when you talk about automation, a lot of manual tasks can be automated. That is true, right? But not a lot of approaches can't be, is what I'm saying, right? Ideas, machines, till the computer systems evolve to a phase where artificial intelligence evolves to a way where machines itself can generate better ideas than human. Only then when system design could come to an automation phase, which I don't see happening in like the pretty near future. I don't see it happening for now, to be very honest. And even then, if that happens, then there would be some ways that people would be able to take control of these things, right? So system design will not be automated, at least not in this lifetime, is what I'm saying. In terms of automating it, what is importance to be good at cp? So you need to understand this, right? Competitive programming is important in terms of having good problem solving, right? The thing that people don't understand about cp is just another way of getting good at competitive to be good, another way of getting good at problem solving, right? it is not necessarily it is not necessary to do cp, to be very honest, right? I haven't done much, but it is not the only, and it is also not the only way to get good at problem solving. It is just one of the ways to get good at problem solving. Okay. Now, for system design, problem solving is one of the key characteristics, right? Because when I say that design YouTube or design Uber, until unless you're able to solve the problem of how Uber works, you will not be able to design it, right? Until unless you're able to solve the problem that how when somebody books a cab and somebody, how does that matching happen? Like the driver and the customer are matched. How does that happen? You need to solve this problem by yourself, right? Using some algorithm, some technique, something, right? So that is where your problem solving is kind of very important. Now, if you are working on problem solving via cp, like if you're improving your problem solving via cp, then that becomes important. But the final goal is to be a good problem solver, and as long as you're a good problem solver, it does not matter whether you're good at cp or you're not good at cp, to be very honest.
Okay, so next question is from Dera again, who is asking, for a fresher role, do we need to practice multi-threaded programming? Which programming language do you recommend for it?
No, so for a fresher, multi-threading is actually not required. Multi-threading comes at, let's say, at 1.5, 2+ years of experience, where people start asking few multi-thread related questions. But for a fresher role, you don't need to worry about multi-threading. And whichever programming language you're comfortable with, if you want to read about it, first read the concepts, and then whichever programming language you're comfortable with, you can start using multi-threading there. There is no like recommended programming language for that. You can use whatever programming language suits you for that.
Okay, so let's move to the sheet now, to the link which is provided. I hope you have filled it. I'll check out the sheet now, and let's address some questions from there. Okay, so this one is a pretty basic question. Where to learn system design? And this is asked by Abhijit.
Okay, cool. So there is two things, right? First of all, there is no one way to learn system design. Okay, what normally people do is that they try to first understand how, what I've seen people doing is that they see a lot of YouTube videos, they read book on system design, like rocking the system design interviews and everything, where there are problems and solutions for a system design interview, right? I It is good to do that, but I think the basic fundamentals need to be clear before you start doing that. Okay, so what I would do is I would suggest you to actually first of all learn the fundamentals of a good system, right? You should understand what availability is, what maintainability is, what consistency is. You should understand how to do replication. You should understand what partitioning is. You should understand cap theorem. You should basically understand the fundamentals of distributed systems before you go to system design. For that, there are a lot of good books, but my favorite one is Designing Data Intensive Applications. I think that's a pretty good book to start with to understand, how distributed systems work under the hood, right? That is a good book to go by. Apart from it, now once you have that fundamental knowledge, then you just need to learn the structure of it. Okay, what I normally tell people is that you need to learn the structure. Why? Because if you know if you have all the knowledge, right, in this world, but again you don't know how to put it forth in front of the interviewer, you will not succeed. Communication skill is very important in that respect, and structure kinds of gives you that skill, right? Because having a good structure will help you to understand how should I approach this problem correctly. For that, you can then maybe move to YouTube videos. You can move to, rocking the system design. There are many courses as well that a lot of companies conduct these days, right, to understand, to explain system design and its concepts. You can take one of those if you need somebody's help. You can set up time with people. You can have mock interviews with them to understand how a system design interview should work. And a lot of that things are there in place now, where this tech community has grown now, right? Earlier, people used to be much in silos, but now with a lot of these things that have come up, right, like Geeks for Geeks, like other places as well, where people are able to contribute back, and you can, you know, use their help to learn some of these system designs. But what I would say is, before moving to system design problems, I would suggest you to first learn about the fundamentals of systems and the fundamentals of distributed system. Then only it would make sense to be able to talk about what system design um, should be like, how should a system design question be answered. And then you can check for variety, like how Uber is answered, because it's a different kind of problem. How Netflix is designed, because it's a different kind of a problem, right? Uber is a different, then for example, from Uber you would know about something else, from Netflix you would know about something else. So then maybe it would make a lot of sense, but initially learn the basics and use them, right? Because, and the problem that we see is that a lot of times when people have, let's say, read from some book or something, they are not able to think outside the box for a new problem. Okay, or even for that problem, if somebody asks you a question with a bit of depth which is not covered in that book or in that YouTube video, you may not be able to answer it, right? So always make sure that whenever you are learning it from a YouTube video or from a book as well, make sure that you first understand, try that problem yourself, figure out, what all systems, how would you make it and everything, then read it on the book or on that YouTube video, and then compare. It is possible that your solution is actually correct, right? Because there is not one way of designing that system. So if you think that your solution works, then it's okay. It's not a thing to get demotivated if the book proposes a system, or the YouTube video proposes a system which is way different from your system design. So I think that is the way. First, focus on your fundamentals, and then move to the next set of things where you talk about system design problems and then master them one by one.
Okay, next question is this one is from Gaurav Tyagi, and he's asking what is the order of priority of topics for FANG interview preparation?
Okay, so I'll tell you. Let's say if you're moving for SG1 kind of a role, right, which is the entry level role at any FANG, right? Um, there maybe coding is more important, right? Now, see, first of all, don't like another thing which I see is that people kind of dread competitive programming, right? Don't do that. Okay, don't think about competitive programming. You don't need competitive programming at all to be able to succeed in a FANG interview. You need basic understanding of data structures to be able to solve good problems on it, which you can practice on multiple forums that we have, right? Geeks for Geeks being one of those, right? You can practice questions on trees, you can practice questions on graph, you can practice questions on DP. There is no order of priority that way in those questions. Why? Because depending upon interviewer to interviewer, people can ask any question. Okay, a lot of interviewers would ask DP questions. A lot of interview would not ask DP questions. They'll ask graph questions, right? So, and again, DSA is the bracket umbrella of everything. So you cannot compare DSA with graph traversal, right? DSA is the bracket of everything, right? So the point is that you should have good concepts, good understanding of your concepts of DSA, and you should have good concepts of understanding of your problem solving coding algorithms as well, right? What I would say is just, do some problem solving, like, start practicing, start with the easy ones. Okay, once you do enough of the easy ones, then start with the medium ones. You will start seeing some patterns. You don't need to be able to solve all the problems to get into a farm interview, right? That is not the expectation. You will, sorry, most of the times it's okay if you're not able to solve the questions completely end to end. It is most of the time important that you are able to think in the correct direction. You are able to think about the correct data structure. You are able to think about the correct approach of solving that problem. So learn that. I think that is what is more important when you talk about SD1 kind of a role. For SD2 kind of a role, now obviously your first 2 3 rounds would only be on coding, right? But when you go for like the last round or something like that would be more on LLD and HLD. That is where it kind of becomes important for SD2 and SD3. And again, it also depends upon companies to companies, right? Like Google will give you a choice between all coding and three coding, one system design kind of around as well, right? Whereas Amazon would have, let's say, uh, two coding and one system design kind of around, right? So company to company, it will depend upon like which company will have more preference over coding, which company would have more preference over um, LLD, HLD. Again, company to company, it will depend that a lot of interviewers of those companies could ask you questions on DP. A lot of them may not, right? For example, Microsoft does not ask a lot of DP questions, right? Like not technically FANG, but yeah, still a good, like great company to work for, right? It's still in that category. I keep it. So the point is that depending upon company, you should actually figure out what you need to read and what you need to prepare for. There is no order as such, because let's say if for Amazon HLD LLD is important for SD to interview and you fail it, then you are not going into Amazon, right? Because even though you did coding well, they'll maybe offer you SD1 position and not an SD2 position, despite you should be going at SD2 corresponding to your years of experience or corresponding to your salary or corresponding to your ambitions, whatever it is, right? But they're not going to offer you that. So there is no order of priority. You need to complete all of these topics. You need to learn them well, and you need to be able to explain them and solve the problems accordingly in the interviews.
Okay, can you suggest some system design books for beginners, as asked by Mohit Sharma?
Okay, so as I mentioned, right, the initially what I feel is that designing data intensive applications is a very good book to get some good concepts on how distributed systems work. Before that, if you, and this is in with the assumptions that you have a basic understanding of how system works, right? If that is not the case, then I would say then maybe go to a book of DBMS or OS first, right? Understand how OS works, understand how DBMS works, at least get the basic understanding of all of that, and then move to distributed systems, because distributed systems are complex, right? If you don't understand how the system works in one computer, it is very difficult to understand how the system works across multiple computers, right? So first understand the basic functionalities of the system, like how OS works at a general level. You don't need to go into depth of lot of things, but you should have a basic understanding of how disk works, how RAM works, or what is the problem between RAM and disk, or how does caching works and all of that stuff, right? How scheduling works, if important, right? For DBMS, it becomes a lot more important, why? Because until unless you understand how DBMS works, a lot of your system design would not be very clear, because databases become a very important part of your backend system design, right? They're the very important part. So you need to understand first DBMSs, and then you can go back to, then maybe start with designing data intensive applications. Then there is a book like Pattern Enterprise Architecture, which is again another good book. Once you have a basic understanding of how systems work end to end, then you should maybe come up and read about grokking the system design, books like that, because those books have questions and answers kind of a thing, right? Where they have a system design question and then they have a complete solution to it. So I think that should only be done once you have basic understanding of things, because that is going to help you in long term in your system, in your system design interview category. Once you have that fundamental understanding of your systems, then you're kind of unbeatable, right? Because you know that what all people can ask, what all depth they can go into, and you will have decent level of knowledge to be able to understand at some level of depth. And that's okay. You may are not expected to know everything and at the correct depth, right? And it's okay as long as you're able to justify a lot of your answers. That is pretty good. So I think that is how you should start with system design interview practice.
Okay, next question is asked by Varun. He's asking, if I choose no SQL DB for certain scenario, then also I need to consider sharding strategies. I read somewhere that for SD interviews, we should try to work with SQL DBs only and make it scalable.
Okay, so Varun, this is an actually interesting question. Why? Because think of it like this, right? Why do you even need sharding? That is where the question should come from, right? And if you had attended this webinar, right, we talked about that. Depending upon the kind of data that you have, depending upon the kind of scale that you have, you would decide whether you need sharding or not. Let's say if your data is in some GBs, let's say if it is just 200 GB or something, then why not you would just keep it in SQL and have only one instance and not shard, right? Why do you need to shard that data? You don't need to shard the data at all, right? Sharding only comes into picture when you have such amount of data that you cannot put it in one machine. That is where you need sharding, right? So if you're choosing NoSQL DB, then maybe because a lot of NoSQL DBs are actually built on top of are built with the consideration that you would need some sharding. So, for example, if you're using DynamoDB, then you have to mention what is your partition key, right? Until unless you mention your partition key, your DynamoDB wouldn't work, right? So, in that case, you will have to consider your sharding strategy if you're using a NoSQL DB. In SD interviews, we should try to work with SQL only when there is less data. But let's say if you're talking about data at a scale of Facebook or YouTube or Amazon, right, which is pretty high scale, then maybe SQL DB is not the way to go until unless you have strong consistency. Why? Because the and you can very well mention that I am going to use SQL, but I am going to shard it, right? Because your one instance would not be able to store all of that data in that machine. So you will have to use multiple instances, and then you will have to shard your SQL DB also. Then you will the only challenge with that is that you will have to make sure that you have in-house sharding capability for your SQL DB, or you use something like Vitess, which has the capability of making it like making sharding, making the SQL DB shardable, right? You will have to take that pain. The good thing with NoSQL DBs are that they are promoting that out of the box, right? For DynamoDB, I'll just tell that this is my partition key and that's it. I don't need to worry about which shard the data goes, how does it read it from, how does it work behind, right? I don't need to worry about all of that. So that is why NoSQL DB is kind of preferable in when you're talking about very large scale data, until unless there is a strong consistency kind of a requirement where you may again move to a SQL kind of a thing if required. Then what also happens in system design is that people go for multiple hybrid choices. For some data they will use SQL based because it is strongly consistent need small data, so we'll just put it in SQL. And for some other data I'll move to a NoSQL DB kind of a thing. Let's say for movie, right? For storing all the movie and the details I may use a NoSQL DB, but for storing the booking information about a movie or something like that, I may use a SQL DB, right? So those things can also work. So I think that is why if you are choosing NoSQL, you are kind of bound to choose the sharding strategy. You're bound to talk about sharding strategies in those cases.
Okay, so this will be it for today's questionnaires. And thank you so much, Priyan, for today's session. This was a lengthy and a very large, like, was a lengthy webinar, and you handled it quite well. So
Thank
thank you
you,
for
Shi.
this. And I hope the students got a lot of things about all of the system design things. And thank you once again, Priyansh.
Thank you, Sheil. I think it was a great experience, right? I had great joy in talking about all of this. I hope a lot of the people who are watching me get benefit of all of this and they are able to, make significant improvements in their system design journey. That's it.
Yeah, definitely, definitely. So this is for the audience. We have a much more bunch of webinars coming up. Next one is tomorrow with about all the interview preparation things hosted by Siddharth Hazra at 6 p.m. You can tune in then and get a lot about that. So I'll be ending this session, guys, and I'll be meeting you again in the upcoming webinars. Thank you all. Stay home and stay safe. Thank you. Bye, Priyansh.
Thank you, guys. Bye bye. Have a great day. Stay home, stay
Bye.
safe. Bye.
You too.